Okay, let's take these first ones.
Okay.
You can learn something by just listening because this could bring you back to sixth grade level momentarily.
Okay.
And then you've got two ratios here, and there are a number of ways of doing it, and they all end up giving the same solution. But I want to see which one they decide to use because I'm sure you go back. Okay. As you know, when you get a fraction equal to a fraction, you can cross multiply. And then that gives you an equation, and then you start solving it using all the rules that you learned right now. Now, some of this you will not understand, but you'll recognize it as a fraction. This, I think, it could even you to learn right now. If I just take that fraction right there, if we solve it, it must work. Just like any equation, you solve it, the answer should be checked out. So if we're looking at this, is there a value of x that we'd have to reject? We love to divide by zero. No, divide by zero? No, there's no solution. So if we get an answer, and as we do this, that ends up making this zero, we have to eliminate it, even though mathematically it came off.
So we eliminate that.
No, can't do that because this is not a factor of that denominator.
Okay.
If we're x times something in a quantity, then that factor would up that factor. But this is a part of an expression, and you cannot take pieces of it. So if we do get 6, we'd have to eliminate it. And what would make that 6? What would make x minus 6 0?
X plus 6.
No. X, the value of x, that would make x minus 6 0. A positive 6. 6 minus 6 is 0.
Got it.
If this had been positive, now add these two, then what would value would not be allowed. If this were x plus 6. Okay, I'll just interrupt. Okay. If you can't do it in your head now, and you did it very quickly, if you can't, just set it equal to 0. Then add a negative 6 to both sides. Sound familiar? 0 here, therefore you get x, because that's why he added the negative 6 to get rid of it. But now you have this over here, so x is negative 6. You look at it. Okay, I said that is x plus 6. Then I said make this plus, and then you check it. Okay, very simple. So that eliminates that. Okay, now, but this problem, the positive 6 would be a value you can't accept because it would be dividing by 0, which is undefined. What, just taking this, wouldn't be allowed as a solution. X minus 4, positive 4, will make that 0.
I'm really glad you understand this, Katie.
Okay, but I think you do. You're not comfortable. Let's put it that way.
Yes.
Because if you have x minus 4, what could cause that? A value of 4. Excuse me, I said it answer myself. What value of x would cause that to be 0?
4.
That's it. And if you want to work it out, you do what I did up here and add a positive 6. 4 here, positive 4 here. You get x equals. But something like this, I think it's quicker to just do it instead of doing it. Okay, now, you've both done problems that look like this. 2 over 3 equals x over 12. And you're asked to solve for x. You know, you did a lot of that in the book.
Yeah.
Okay? And I'm surprised, but the book says cross multiply. I know she's done a lot in the last few months because I've subbed in that class. So you multiply these two, and what is that?
3x.
3x. these two fractions are equal, the two products must be equal. So you get 3x equals 24. Divide both sides by 3. X is 8.
So you divide this by 3, divide this by 3. Got it.
Okay. You're pretty quiet. Okay.
She's pretty good.
Okay. But except you follow. Now, let's prove it's right. This fraction is equal to this fraction, right? That was given. Given the choice on it. Now, if I put an 8 up here, can you do something that you've done hundreds of times that would prove this is equal to that? Reduce it. What can you divide both of these by?
2
Okay.
or 4.
Or better one. But I quickly started since you wouldn't change your mind. Because if you don't get the right combination right away, it just forces you to do it 2 more times. No, 1 more time. So you get 2 of it. So these problems can be checked very, very easily. Okay. This was a simple problem. Well, these aren't even that much more difficult, but you have more writing. More writing. All right. So you have x over equal to 1 over x minus 4. And we've already decided the solution cannot be a 6 and cannot be a 4. So if we get these, we have to eliminate them. Well, I looked at the problem. They aren't there. So we're safe. But just like before, you multiply that. You multiply that. 1 times that is x minus 6. Agree?
X minus 4. X squared.
That's right. X squared minus
4x.
You agree?
Yes.
Distributive problem. That's x minus 4. That and that, right? Which are x squared minus 4x. You've done it. Yeah, but I mean,
Yeah.
this is not new, but not involved in this kind of
Yeah.
You did do this, but I know you have that. Right, because these two ratios are defined, given to us as equal, we can now assume these two are equal. Now, we're going to lose you now. Okay, we want whatever it is equal to 0.
Okay.
So, basically, I like this side the way it is. So could I add the opposite of x to this side, and then we get rid of that? Add the opposite of 6 to this side. So we add the opposite of x. And I know the 8th grade book does a good job on this. Subtracting can be changed to an addition problem by not. That's right. Look here, shaking your head. So if I add a positive 6 to this, have I gotten rid of this? I've gotten rid of this. Now have I got the 0 I'm looking for?
Yes.
So we're in the same. But now we got to add the same thing to this side. Okay. Well, I'll leave the x squared fine, because that's the highest x one. But we're going to add an opposite of x to this negative 4x. What would that total up to?
4x.
We're adding.
Oh, negative.
Negative x is the same as negative 1. And you
So
get a negative 4.
3.
Now this is a negative 4. So it's a negative 5. Okay. And now we also added a 6 to it. So we've taken care of these. Now I can add the 6. We have a quadratic formula. And we're going to keep losing you. There are how many different ways of solving it that you can think of? Quadratic formula.
Oh, excuse me.
Yeah.
I don't know.
There are 3 of them.
Okay.
One is to graph it. And it's going to be something like this. And wherever it crosses, that are your solutions.
Oh,
Okay,
okay.
I don't like that. As long as it hits whole numbers, you're fine. If it comes in someplace between 2 whole numbers, you guess it. So it's no good. Okay, the next one is if you can factor. Let's say you factor something like this. You get x minus 2 times x plus 3. And let's pretend this is this.
Okay.
Okay, don't want to do a fraction again. Well, if this is this, then since this is 0, this is 0. Now, this is a product. This is multiplied times this, right? Okay? If I have a number like 3 and x, I just say pretend that's that, this is it, and I want that to be 0. What's the only way that can be 0? We're saying 2 times something has to be 0.
-3.
Okay, let's see. 3 times a negative 3. Negative 9. Easy.
Goodness.
Okay. 3 plus a negative 3 would be 0. But this is multiplication.
Okay.
Did you hear what she said?
Yes.
What is it?
0.
This is 0. I don't care what this is. 3 times it is 0. So x. The only thing that'll make this thing 0 is x equal to 0. Now the same thing here.